So, very good evening to one and all present here. In today's session, we are going to see the next subsequent topic in operation research, assignment model. So first, let us have the outline about assignment model. What exactly assignment model? According to the fundamental principles of operation research, is defined as a method of allocating n number of different resources in which how each resource is assigned matched to a particular task. In general, the resources can be classified into three major types: monetary resource, say financial resources, personal or human resources, or technological resources. These are the different classifications of resources available in a manufacturing organization. Now let us in depth understand the assignment method more further. The next consecutive information. Let us take an example of a production process, how assignment method can be practically applied to job production process. See, in this case, example, the assignment method is used to determine arrangement of different machines and job scheduling. And next thing, which are all the jobs have to be assigned to the corresponding machines according to the nature of operations. This is one such basic example of the problem classification, job versus machine scheduling operation. So the assignment method can be very well adequate to such type of real world the problem. The primary goal is to set different resources in such a way that we can enhance the production efficiency by maximizing the profit by controlling the unnecessary wastage in the production cost. This objective is related to production process regarding assignment method. Let us see some other general applications of assignment method as per the real world scenario. The first one, allocating the proper number of employees to the specific number of machines to perform the job. Second one, allocating a group of machines into the manufacturing plant in order to produce as many number of products. Last example, assigning number of salesperson to a given territorial region in order to plan for the sales operation. So these are some of the practical examples in which we can be able to solve through mathematical application the so-called assignment model as listed out here. Now let us go with a numerical exercise, numerical problem for practice. Let us take a computer center. In the computer center, there are 4 programmers working in the computer center. The primary duty of the programmer is to develop customized software, say application program. Here we have to find out what is the minimum time required by the programmer expert to develop different variety of application programs. So here the following table given here for your reference. So it is a 4x4 matrix. The row represents the program experts. Column represents the application program or software. So each programmer has to develop 4 application program software application for the company. And this number represents the process time in minutes. How to read this table? Say for an example, the programmer 1 takes 120 minutes of time to develop application program A. Likewise, programmer 1 takes 100 minutes process time to develop the application program B. Likewise, the same programmer 1 takes a process time of 80 minutes to develop application program C. The programmer 1 takes 90 minutes time to develop the system application program D. So, to take the first programmer, there are 4 different set of timings given under each job operation. We want to find out the overall the minimum time at which all the 4 expert programmers able to complete the 4 different variety of tasks. Likewise, the other remaining 3 rows in the table, the corresponding time slots has been given in minutes. So this is the question, the original, the problem design. And what we are supposed to find using assignment pattern, we have to calculate the minimum time required for preparing those application programs by 4 experts, programming experts. So this is the question asked in the problem. Now we are going to see the solution approach, how to solve the above problem. By applying Hungarian rule for assignment problem, first thing, we need to identify the row minimum element. Here there are 4 rows are there, 4 columns are present in the table. So you take the first row, identify the minimum element, 80 is the minimum value. Similarly, second row, 70, third row, 100, fourth row, 80. So each row you have to identify the minimum element. Okay. And we need to subtract the row minimum with the corresponding row numbers. Let us see how. Here, say for an example, you take first row in the table. The row element 80 is considered to be the most minimum in the first row. So select that number 80 and that has to be subtracted from every element of the first row. So 120, 100, 80 and 90. Likewise, we have to repeat the same operation for the other remaining 3 rows. Now let us see how the resultant matrix looks like. So this is the final resultant matrix. Let us see further how these values are coming out. See, 120 minus 80. So in the first row, the minimum value is 80. So subtract the minimum value with the available number in the first row. 120 minus 80, 40. 100 minus 80, 20. 80 minus 80 is 0. 90 minus 80, 10. You can see the first row in the resultant matrix, 40, 20, 0, 10. Likewise, second row, which is the minimum value, 70. So take that value outside the table and subtract the same value with the remaining numbers in the second row. 80 minus 70, 10. Then 90 minus 70, 20. 110 minus 70, 40. 70 minus 70 is 0. So this is how the residual value for the row number 2. Likewise, for the third row and fourth row, we have to do the same operation instantaneously. So the minimum value is 100. So 110 minus 100, 140 minus 100, 120 minus 100, 100 minus 100. Okay, so you see the third row value, the new value 10, 40, 20, 0. So last row, fourth row, minimum value is 80. So subtract 80 with the 90. 90 minus 80, then B minus C, that is 90 minus 80. 80 minus 80, then 90 minus 80. So you will get this value 10, 10, 0, 10. So these are the new revised resultant matrix after identifying the row minimum and subtracting the row minimum with the existing value in the corresponding row. Likewise, we have to do the same operation for the column, each column, A, B, C, D. So let us subtract the minimum element of each column. Say you take the first column A, 10 is the minimum value. Okay, take that value separately and subtract the value 10 with the remaining existing numbers in the column A. 40 minus 10, 30, 10 minus 10, 0, 10 minus 10, 0, 10 minus 10, 0. So you will get this value for column A, 30 triple zeros. Likewise, we have to do the same operation for column B, C, and D. We take column B, which is the minimum value column wise B, 10. So 20 minus 10, 20 minus 10, 40 minus 10, 10 minus 10. So you can see 10, 10, 30, 0. This is the revised value by subtracting 10 with the remaining values of the column B. In column C, 0 is the minimum value. You will get the same repetition as such 0, 40, 20, 0. At column D, 0, again 0 is the minimum least value. So subtract 0 with the remaining number 10 minus 0, 10, 0 minus 0, 0, 0 minus 0, 0, 10 minus 0, 10. So the last column also we will get the same repetition of value. So now what we have done, just by selecting the row and column, we found out the minimum value from each row and each column. And in turn, we have subtracted the row and the so once again, let us recap the steps. So initially, we have found out the row minimum and the column minimum. After finding out the row and column minimum, we have subtracted those particular value to each row and column. And this is the final table we got. Now we have to select the number of zeros in each row and each column. And we need to make a square box, the corresponding zero in each row and column. That is the next operation you are supposed to do. Again, redraw the table. Take row number 1. Here we have only one single zero. The condition is select the row which has only one single zero. Don't select the row which does not have more than 1 0. Okay. So we are going to work out this problem in two multiple cases. As per case 1, we are going to select one single zero. So fortunately here in the first row has got one single zero. So make a square mark around the particular the zero region and select column C. Check whether is there any other zero in the column C. Yes, exactly. Extra one more zero you can able to see in column C. Put into mark the column C Well, so this clearly shows that we have to put a rectangular square and we have to delete the other zero in the same column. Here you can able to see the statement. Starting from the first row onwards, we can draw a rectangle around the zero in each row, having a single zero, and make a cross mark on all other zeros in the corresponding column. So this clearly shows that take the first row, okay? Here we have only one single zero. Select the particular zero value, do a square mark, and check in the same column, is there any other zero? Yes. The last row, third column, we have one extra zero. So we have to delete that additional value by making an into mark or a cross mark. So this is the procedure to be adapted for each row and column. So as of now, we have selected 1 0 with a square mark. Now go to the second row, third and fourth row. There is no single zero. The second row. 2 zeros are present in the second row. Similarly, third and fourth row, 2 zeros are there. So the conditions cannot be applied for the row operation. Now you go to column-wise operation. Since row operation is not possible because in only one row it has got single zero, except the first row. Whereas all other remaining 3 rows does not have single zero value. So let us terminate the initial process, switch over to the column-wise operation. So therefore, we have to move to the column-wise operation in order to check is there any column which has a single zero or not. So go to column A. There are 3 zeros, not possible. Now move to column B. We have only one single zero. Select column B, make a square mark. So the second zero element is selected with a square mark. Already 1 0 is there in column C, selected with a square mark. Likewise, we have to select the second zero value. And see the fourth row, the corresponding row. Delete the zero which is present in the cell 4, A by making an into sign. Okay. Once again, I repeat the statement. In column B, we have one single zero. Select column B. Okay. In the selected column, refer to the particular row. Is there any other extra zero? If it is there, means we have to select the particular row and delete the full complete row. So here we have deleted the fourth row. So 2 zeros are there. So we have deleted the 2 zeros on either side, both left and right hand side. Again, we have to do the same operation row wise. So column C, already we have selected 1 0. Go to the fourth column D. It has 2 0. It is not possible for selection. Again, switch over to row operation. You take the first row. First row has been designated already with the single zero. We have to go to the second row. Here in the second row, 2, A, 2, D, 2 zeros are there. So we have to select any one of the zero randomly by deleting the other zero. So here in this case, let us draw 2, A. That is the zero which is represented in the cell 2, A is being selected by marking the square mark, and 2, D, 0 present in the 2, D that has been ignored by making an into mark. Likewise, go to the third row, 3 comma A and 3 comma D. Two zeros are there. Do the same repeated operation in a similar manner. Here I am randomly selecting 3 comma D. So put a square box for particular zero located along 3 comma D and delete the zero which is present in the cell 3 comma A by making into mark. So totally there are 4 zeros are marked with the square box by deleting the other remaining zeros in each row and column. This clearly shows that there must be only one zero left with every row and column. You have to select only one zero with respect to every row and column by mentioning a square or rectangle box symbol. So this clearly mentions that we have to assign only one operation to each programmer so that we can able to get the optimal solution. So from this table, we came to know that the programmer 1 is assigned to develop application program C. Programmer 2 is assigned to develop application program A. Programmer 3 is assigned to develop application program D. Programmer 4 is assigned to develop application program B. So only one operation is assigned to each program expert. So this is what the ideology of the assignment problem. So we can see the final result here. 1C, 2A, 3D, and 4B. So let us see the further results and discussion more detail. So from the above, the optimum solution, it is clear that the programmer 1 will be assigned to do application program C. Likewise, the programmer 2 is assigned to application program A and so on. What I told you earlier in the previous slide. And we have to find out what is the minimum time taken in developing the 4 application programs by all the 4 experts. So let us go to the original timetable of assignment problem. See the question. Now the programmer 1 is assigned for application program C. The corresponding time is 80 minutes. So the programmer 2 is assigned for A, developing application program A. The corresponding, the original process time is 80 minutes. The programmer 3 is assigned to develop application program T. You can check the result. So the corresponding original time for developing the application program T by expert 3, 100 minutes. Programmer now expert 4 is assigned to develop application program P, whose corresponding original process time is 90 minutes. So we have to add the selected process time, find out the minimum total time. 80 plus 80 plus 100 plus 90, totally 350 minutes. So these values are taken from the original timetable of the given assignment problem. How I get this number? We have to go according to the sequence. By following the sequence, refer the time value from the original table and calculate the total minimum time taken to develop all the 4 application programs by various experts. Now, the conclusion of this concept, according to the operation research, the context, the so-called assignment model primarily focus on scheduling different varieties of tasks and the corresponding resources in order to complete the given work done within the minimum span of time. This can be otherwise called as one-to-one correspondence problem. So with this introduction, I conclude today's topic. So thank you all. The next meeting, we will discuss the following segment in operation research. Thank you once again.